Hello children, so these are type B numericals in which we will use dimensional analysis to find out, to derive formula, expressions, okay, and relations. So let us see the first numerical, which is the velocity of water waves may depend upon wavelength. So velocity is depending upon wavelength. We don't know to what power, so we will write A. Then density of water, symbol is rho, they have mentioned. So it is depending upon velocity, is also depending upon density, to which power, let us say B, and acceleration due to gravity. So velocity is depending upon acceleration due to gravity to the power C. Now we'll combine these three equations, equation number 1, 2 and 3, we will combine. So velocity is proportional to lambda to power A, rho to power B and G to the power C. Now we will write the dimensional formula of all the quantities. Before that we would just remove proportionality constant and we'll write a dimensionless constant. This is proportionality constant, or you can say dimensionless proportionality constant, or some constant. So what is lambda? To power A, rho is density to power B and G is acceleration due to gravity due to power C. Okay, now what is a wavelength? Wavelength is a kind of length. So dimensional formula is L. Density is mass upon volume. So it is m by L cube, that is ml to the power minus 3. And acceleration due to gravity is your Lt minus 2. Right, so we'll substitute, and this velocity is distance upon time. Upon time is t to the power minus 1. So we'll substitute here Lt minus 1 equal to k as it is, dimensionless constant. Lambda is L to the power A. Density is, this is density. So it is ml minus 3 to power B. And acceleration due to gravity, that is Lt minus 2 to power C. Now we'll open the brackets. So left hand side as it is, L, we can write m0 because m is not here, Lt minus 1. So L1 t minus 1 within square bracket is equal to constant. It will be L to the power A. We are opening the bracket, so m to the power B and L to the power minus 3B. This B will be given to it, right? So it is L to the power minus 3B. और यहाँ पे क्या आ जाएगा? L to the power C and T to the power minus 2C. Now we would use mathematics. M to the power 0, L to the power 1, T to the power minus 1. K as it is. We will add all terms of L. Let us add all terms of L. So this is L to the power A, this is L to the power minus 3B, this is L to the power C. So we'll add A minus 3B plus C. With sign you write down. Then let us write for M. M is only B, there is no term of M, and then time is only minus 2C. Right? When base is same, powers are added. Now we would equate the powers. Equating exponents. Equating exponents, equating powers. So m to the power 0 should be put equal to B. So 0 is B. So B has been found. Done. L to the power 1 should be equated to this. Let us put 1 should be equal to A minus 3B plus C. And T to the power minus 1 should be equated to minus 2C. So minus 1 should be equated to minus 2C. Minus minus cancel. So C is equal to 1 by 2. Okay, C is 1 by 2, B is 0. We will substitute both the values here. C is 1 by 2. B is 0 is equal to 1. So half will go this side. So 1 minus half is half. Okay, so I'm ready with all ABC. So B is 0, A is half, and C is half. Now we will just substitute in this equation. This equation we will substitute A, B and C. So it is lambda to power A, rho to power B and G to power C. So velocity is equal to constant lambda to power A, density to power B, G to power C. Let us substitute. B is 0, A is half, so lambda to power half, rho to power 0 and G to power 1 by 2. Rho to power 0 is 1, anything raised to the power 0 is 1. So lambda to power half and G to the power half. So half is your square root. So it can be written as lambda G to power half. So this can be written as root lambda G. So this is your formula. So we could derive the formula of velocity which depends upon lambda and G using dimensional analysis. Let us see the next question. A small steel ball of radius r is allowed to fall under gravity through a column of viscous liquid. So radius is r just now, till now. It depends upon, they are mentioning coefficient of viscosity eta. Okay. After some time, the velocity attains a constant value Vt, which is called terminal velocity. The velocity depends upon, okay. So terminal velocity depends upon, first is the weight of ball, mg. So it is weight of ball to power A. Then it depends upon, second quantity is coefficient of viscosity to power B. And radius also it is depending upon, so radius we will take to power C. We have to produce the expression for velocity. Okay, so we'd combine these 1, 2, 3 equation. Let us combine. So terminal velocity depends upon weight to power A, eta to power, that is coefficient of viscosity to power B, and radius to power C. Now they say that weight is mg. That everyone knows from class 9th. So Vt is equal to some constant will come. Weight is written as mg to power A. It is eta, or let us not open it as mg, simply we will keep it as weight to power A, coefficient of viscosity to power B, and radius to power C. Now let us discuss about the various dimensional formula of these quantities. Weight is mg, mg is m, and g is lt minus 2. Eta is coefficient of viscosity. We have seen in previous video, and in dimensions also it is ml minus 1, t minus 1. If you remember, it's okay, otherwise you can find it out. And radius is length. Let us substitute. And velocity is distance upon time, that is lt minus 1. So we'll write it as m0 l1 t minus 1. This I have written left hand side. Now we'll write right hand side. K as it is. W is this. mlt minus 2 to power A. Eta is ml minus 1. T minus 1 to power B. And radius is L to the power C. Now we'll open brackets. Open brackets. So it's m to the power 0, L to the power 1, T to the power minus 1 is equal to K give power A to all. So let us give power A to all. M to power A, L to power A, T to the power minus 2A. Similarly, let us give B. M to power B, L to the power minus B, T to the power minus B. And here only C. Now what will be the next step? We will be combining all the exponents of right hand side according to their base. K as it is. Let us collect power of M. So it is M, A, B and no one else. A plus B. Then let us write for L. It's A minus B and C. A minus B plus C. Now time ki power. It's minus 2A and minus B. Now we will equate exponents. Power of M should be equal to power of M. 0 is equal to A plus B. L power should be equal to L power. 1 should be equal to A minus B plus C. And power of T should be equal to power of T. So minus 1 to be equal to minus 2A plus, minus B. Now we can solve. For example, from here it is coming A is minus B. Okay, so we will write here minus A, minus 2. We are substituting the value of A here. Minus B, minus B. So it is minus 1. It is 2B minus B. So it is B is equal to minus 1. So B is equal to minus 1 by, it is minus 1. Minus minus plus. So 2B minus B is B. So I have got the value of B, which I'll substitute here. So I'm ready with value of A. A is 1 and B is minus 1. Will substitute here. A is 1, B is minus 1 and it is C. So 1 plus 1 is 2. So 2 will come this side. So 1 minus 2. So it is minus 1 is C. So we have got all the variables. A is 1, B is minus 1, C is minus 1. Let us put in that equation. This equation. This equation. So terminal velocity is equal to constant weight to power A, eta coefficient of viscosity to power B and radius to power C. I hope that was radius. Yes. So we'll substitute now values. A is 1. So weight to power 1. B is minus 1. And C is also minus 1. So we'll write it as, these two will come down. R and eta, weight is up. Weight can be opened as mg divided by r eta. And this is the answer that you need to confirm. Mg by eta r. So let us see the next question. Let us see this question. A uniform string of length L is stretched to under a force T. If the frequency of vibration N, according to them, frequency of vibration is N. Okay, and it is assumed to depend upon, so frequencies depend upon, usually frequency is taken by nu, but it's okay, whatever they have said. The frequency depends upon, first quantity is this load applied. So this is your load applied to power A. Load applied is force. You can see it is clearly written force T. Okay. Then frequency, Usually symbol is frequency is this, but whatever they have said, we will follow that. So length is the second quantity that it depends upon. Third is mass per unit length m. Mass per unit length m to power c. So we will see. Okay, we will combine these three equations. It is coming as T to power A, L to power B, M to power C. Just be sure T is force, L is length, and M is mass per unit length. Now we'll see dimensional formula of force is MLT minus 2, length is L, and mass per unit length is ML minus 1. Let us substitute here. I'm sorry, this frequency is also there. So this is your frequency, and frequency is reciprocal of time, so it is t minus 1. So we'll substitute here t minus 1 is equal to some constant. This is force, this is not time period, this is force. So mlt minus 2 to power a, length to power b, and this is mass upon length, ml minus 1 to power c. Simply open the bracket. This can be written as m0 L0 t to the power minus 1 is equal to k, open bracket, m to power a, L to power a, t to power minus 2a, then open next bracket, L to power b, this one, and then next bracket will give you m to power c and L to power minus c. Now this is m to power 0, L to power 0, t to the power minus 1 is equal to k. Combine powers of m. So it is a plus c, then L, a, b minus c, a plus b minus c. Now time to the power minus 2a. There is no other time, so this is okay. Now we'll equate powers. Power of m should be equal to power of m. So 0 is equal to a plus c. Power of L should be equal to power of L. So 0 should be equal to a plus b minus c. And t to the power minus 1 should be equal to this minus 2a. So it is coming as minus minus cancelled. So a is coming as half. We'll substitute half here. So 0 is equal to half plus c. C is equal to minus half. Okay, now we'll substitute a and c here. A and c here. 0 is equal to a is half, b as it is, minus as it is, and c की value is minus half. So 0 is equal to half plus b plus half. So b is plus 1 is equal to 0, so b is equal to minus 1. Let us substitute. Our equation is this. Frequency is equal to force to power a, length to power b, and mass per length to power c. So frequency is equal to constant, force to power a, then length to power b, and mass per length to power c. So let us substitute. K, what is the value of a? A is this half, so t to the power half, L to power minus 1, this, and m to power minus half. Okay, so we will write it as n is equal to, what is minus 1 we are bringing down, and this is also minus, it will also come down. So t to power half up, L down with 1 power, and m down with half power. Now we can write it as k by L, and half is root, so it is root t by m. This is what was to be derived. This is the formula for frequency. For a stretched row. But that is okay, we just use method of dimension to obtain this. Achha, this is constant. We don't know the value of constant, so we will write k. Okay? So you can see L is down and this is root T, root M. So here it is. Let us see the next question. Calculate the dimensions of force and impulse, that is second part, in terms of velocity, density and frequency. So we have to find out force in terms of velocity, density and frequency. Force in terms of this, this and this. So force is depending upon velocity, density and frequency. So the question can be asked in this form as well. So we will combine these all three. Force is proportional to velocity to power A, density to power B and frequency to power C. Now same way, we will remove proportionality constant, we will remove proportionality and we'll write a constant. Velocity to power A, density to power B, frequency to power C. Now method would be same. We will write the dimensional formula of these all quantities. Force is mLT minus 2 is equal to constant. So is equal to constant. This is velocity. Velocity is to power A, so it is LT minus 1 distance upon time to power A. Density, so density is mass upon volume to power B. And this is frequency, so it is 1 by T, that is T minus 1. Frequency is reciprocal of time, so this is T minus 1 to power C. Then method is same. We can simply use general mathematics. So let us do this also. Okay, this is m to power 1 L to power 1 T minus 2 is equal to k. Now please open the bracket. L to power A, T to the power minus A, open the bracket here. M to power B, L to the power minus 3B, and it is T to the power minus C. So now you can add up the powers of right hand side. L and L, two terms, so L to the power A minus 3B, mass only one term, mass to power B, and time has got two terms, time has got minus A and minus C. Now you can equate powers and use your general mathematics to find out the different variables and then substitute, and then you can match your answer with this. And similarly, there is one more numerical in which impulse depends upon velocity, density and frequency. Okay, so impulse depends upon velocity, density and frequency. Just remember what is impulse. What is the dimensional formula of impulse? It is force into time. So what is most important? To know the general formula and dimensional formula. Then only you will be able to do these numericals. Okay, so it is M, L. Now powers will be added. Minus 2 plus 1, that is M, L, T minus 1. This is impulse. So kindly substitute and follow the method and obtain relationship and confirm your answer with this, whether you are able to do or not. Let us see the next question. Here we have to find out the formula for Reynolds number. Okay, Reynolds number. And it is depending upon, first is velocity to power A, density to power B, coefficient of viscosity is eta to power C, and diameter. So diameter to power D. This is velocity, density, coefficient of viscosity, diameter, and this is Reynolds number. So we can write down the dimensional formula of both. All LT minus 1, density is ml minus 3, eta is ml minus 1, t minus 1. If you don't remember, you have to derive. Diameter is length and Reynolds number is dimensionless. Now children, there is one more line, we'll have to read it properly. R varies directly as diameter. So R is directly proportional to diameter. It is very important that D is 1. It is varying directly with diameter. That means D they have given as 1. Fourth power, or you can say diameter's power they have given. That is a hidden information. So if somebody is varying, some quantity is varying directly proportional to square of diameter, so we will write power as 2. So please don't ignore this line. It is varying directly with diameter, so power is 1. Now we can simply substitute and follow our routine. M0, L0, T0 is equal to some constant. Velocity is Lt minus 1 to power A. Density is ml minus 3 to power b, and eta is ml minus 1 t minus 1 to power c. Diameter is L and to power 1. Just keep that in mind. Now we'll write next. Now we will open the bracket. You know all the steps now. M0, L0, T0. L to power A, T to the power minus A, M to power B, L to the power minus 3B, M to the power C, L to the power minus C, T to the power minus C. L to the power minus C, T to the power minus C. This is L to the power 1. Let us add up all the powers of same quantities. So let us check M. So it is B plus C. Let us check L now. L and L. So L would be A minus 3B minus C. And time, 1 is also there. Please don't forget this one. LA, L minus 3B minus C and 1. And time is minus A and minus C. Now let us equate powers. So 0 should be equated to this. So B plus C is 0. Second, L to the power this. A minus 3B minus C plus 1 is equal to 0. And minus A minus C is equal to 0. So from here we see that B is minus C and A will go that side. So A is also minus C. So we'll substitute here. A is minus C, minus 3 as it is. B is also minus C as it is, plus 1 is equal to 0. This was 0. I've written 1 by mistake. L power was 0. Okay, so minus C plus 3C minus C plus 1 is equal to 0. So this is coming as minus C 2C minus 2C plus 1 is equal to 0. So it is C plus 1 is equal to 0. C is coming as minus 1. We'll substitute here C. So we are ready with B. B is 1. We'll substitute here C. So A is also found. A is 1. So most important step was this one, that Reynolds number is directly proportional to diameter to power 1. Okay, so ABC has done, so we can substitute. So Reynolds number is proportional to, or you can say equal to constant. Power is A is 1, B is 1 and C is minus 1. So we'll see. V rho eta A, B, C and D to the power 1. So let us substitute. A is 1, B is 1, C is minus 1. A1, B1, C minus 1 and this is this. So it is R is equal to K rho V D by eta. So this is the formula that we were supposed to derive. So kindly practice these numericals, and there are a lot of numericals based upon this type. Just you should know the method to solve. Okay, and don't do any mathematical mistake, and prepare all the dimensions properly. Thank you.